This is a parallel circuit. There are two legs. There are 4 light bulbs total, 2 in each leg. We're going to work through this and find out what the voltage drop is per light bulb. I got some extra credit stuff we'll do. David's recording it for us there. And so if you want to, walk up and get in the picture if you want to there for prosperity. Just remember, when you're doing anything with Ohm's law, Watt's law, series circuits, parallel circuits, or series parallel circuits, remember the 2 pyramids, okay? Remember, for watts, you need to have 2 knowns to find an unknown. And for your Ohm's law circle, you need to find the unknown by knowing 2 knowns. Just cover up the unknown and do the math. Everything sideways, of course, is multiplication. Up and down is division. When you do division, always clear your calculator and put the top number in first, then the bottom number, and then hit equals, and you're ready to go. So, what kind of a circuit do we have?
Parallel.
Don't be bashful, guys. Parallel, okay? And this is a little different than yesterday, isn't it? We have 2 light bulbs in each leg. So we have a 12-volt battery. We have leg 1 here, leg 2 here. That's a ground, of course. And this is the ground. So what I want to know, I want to do a voltage drop on all 3 light bulbs there. So to get our heads where it belongs, of course we need to know the rules of a parallel circuit. Who wants to tell us the first rule? You all have that on your study guide? Yes, go ahead. First rule. Good man. He's not opening study guide. He's got to memorize. You're my hero.
The smallest resistance will be, the total resistance will be smaller than the smallest resistance.
Okay, so that's good to know. So how much resistance is in this leg?
6.
6. And how many is in this leg?
6.
So we'll be figuring this after we stop taping. In other words, the total circuit resistance will be something less than 6, correct? Okay, what's the next rule?
Voltage is the same all over.
Exactly. We have 12 volts going through each leg. But since we have 2 loads or 2 light bulbs in each leg, those 2 will share the 12 volts. So it won't be like my electrical board where on the parallel circuit they were real bright. These are going to be dimmer. One will be dimmer than the other there, okay? And what's the other rule?
Total amps is the sum of all branches.
Exactly. So we have amperage flowing this through this leg and this leg. That is going to equal the amperage here and here, okay? So we want to find a voltage drop, the voltage dropped on both of those bulbs. So let's go over to our Ohm's law circle. So what do we need to know? Amperage and ohms. Well, we already know our ohms, right? So now, we do leg 1 first. We want to figure out how many amps are flowing through leg 1. So let me just. Okay, so now let's go back to our Ohm's law pyramid for amps. So for amps, we need to know what?
Volts and ohms.
Okay, volts and ohms. Okay, well let's go ahead. So we know we have 12 volts, and we know we have 6 ohms. So let's do the math. How many amps are flowing through there?
2.
2. That's pretty easy, isn't it? Right? Remember, anytime you write anything down, make sure that you identify what you measured, amps, ohms, or volts. Because next week you're going to go to the tool crib and you're going to do a little exercise with David. And David is a nice guy, right? But when it comes to grading your papers, he's pretty strict there. If you measure 2 ohms and only put 2 down, he's got a red pencil and he's going to mark it wrong. So always identify what you're going to do it. And that may get you ready for USA Skills VICA if you ever do something like that. Okay, so we know we have 2 amps here. Okay, so the voltage drop on bulb 1, what are we going to do? Think about it, guys. We want to find voltage. We need to know the resistance, right? Right? And amperage. So what have we just figured out as far as our amperage go?
2 amps.
2. So we have 3 ohms times 2 amps is what?
6.
6, yeah, 6 volts. So we come over here. Okay. Now, how many volts are flowing through leg 1?
6 volts.
No, how many volts? 12, okay. And of course, both of these light bulbs need to use up the 12 volts, right? So we had 6 volts dropped on the bulb 1, so we don't even do any math, do we? But if we wanted to, 3 ohms times 2 amps equals 6. So we got 6 volts over here. Is that pretty easy, guys? Okay, let's shift over to leg 2. Okay, so we need to figure out how many amps are flowing through leg 2, correct? Okay, so for amps, of course, we need to know the resistance and voltage, correct? Right? Okay, so we know our resistance, 6, and we know our voltage is 12. So on our calculator, if we would need to, we put 12 in, we clear it, put 12 in, hit divided by 6, what would we have?
Same, 2.
2 amps, exactly right. That wasn't too bad, was it? So now, we want to find the voltage drop on bulb number 3. So we come over here. So to find voltage, we want to know amperage and ohms, correct? Okay. So we already know our ohms, right? So 4 times 2 amps equals what?
8.
Now, really, if we were in a hurry and wanted to get out and get a cup of coffee from the tool crib, you could do a little simple math and how many volts are dropped on leg 4?
4.
4, because we know that both of them are dropping 12, but let's do the math. So here, we know that there's 2 amps flowing through here, correct? So 2 ohms times 2 amps equals 4 volts. The study guide I gave you outlines that just step by step by step. So hopefully it'll help you. Any questions?
No, sir.
No question? David, you and I did a great job. They all know it. So I'm gonna, go ahead.